Hello everyone, we're excited to share with you guys our latest work, EMNLP, open source framework to build the future-ready multimodal conversational agents. Our motivation is very straightforward. OpenAI released GPT-4 on 13 May 2024. The next day, Google released Project Astra, and last week, Tesla launched their robot. It looks like the future comes to the reality, and there are so many opportunities and challenges. So, how we address that? So first, what's the challenging? In our opinion, one of the challenges is like how can we make the multimodal conversational agent the latency is acceptable, and also the response for the domain-specific scenarios is appropriate. So this needed to our definition to two key performance metrics. One is the latency, and one is the accuracy. To get this multimodal pipeline works, that's we have three different solutions. One solution is the traditional solution. We divide and conquer it. The whole pipeline will be split into multiple modules: speech to text, image to text, and a large language model generate the text. And text will be feed into the text to speech module and generate the audio playback. In this way, the problem is very obvious. The latency is very high and it's hard to be compressed down. So GPT-4 proposed another solution, which is a fully end-to-end module. It will take the audio, text, and the images as the input and generate the audio directly, play back to the user, so the latency is very short. However, in this way, we are still not sure how can we ingest the external data into the fully end-to-end module. Another hybrid solution, which can be a potential promising solution for the open source community for now, is voice end-to-end module. So the video is so large and hard to transfer and takes a lot of resources to compute and process. Then we can just produce audio end-to-end module. So the audio and the text data will be fed into this voice end-to-end module and generate the audio automatically. In this way, you can also ingest the video information as text into the pipeline. There are some open source works already in this category. And in our opinion, if we can reduce the latency, reduce the cost, and increase the accuracy, it will make the real-world multimodal conversational agent more applicable. So we designed this system. It will have a client module, gather the video and the audio input, save it to the storage places, and send the metadata to the API side. API side, we're in charge of trigger pipeline, customizable pipeline, which can include the speech-to-text, emotion detection, RAG, large language model, text-to-speech modules, and the result will be reported to the API. The client side will listen to the API side. If there is audio to be played, it will play back to the user. Researcher can come to see the latency benchmark automatically generated by the system, and also can assign some annotators to annotate whether the response from the pipeline is good or bad. So we use US president debate as one of the demo scenarios to understand whether AI can be our president. So we take out the Biden's response when he debated with Trump and feed the question to the multimodal conversational agent. From this latency benchmark, we can easily find out the consolidation large language model generator process contributed the most latency to the whole pipeline, makes the whole pipeline 1.5 minute latency, which is totally not acceptable. And after the annotation by the annotators, we find the overall score for this pipeline response is good. However, it lacks of the domain-specific response and the support evidence compared to Biden. So the conclusion is AI cannot be our president yet, but probably in the future. So I think that's just a starting of the work, highlighted the challenges in the latency part under current hardware constraints. And also from the accuracy perspective for domain-specific applications, is promising for us to resolve it. So we want our work to be able to ease the burden for the researchers and innovators, help them to bring this advanced technology to the practical applications. And if you want to use our code, this is our code base. And we have a demo website. We have detailed documentation about how to use it here. And we have a demonstration video can be accessed from the YouTube. Thank you.